This is the first term, the second term, the third term, the fourth term. What is the shape of the fifth term? We need to discover a pattern. The shapes can be broadly categorized into two types: polygons versus non-polygons, shapes that connect all 10 points versus shapes that connect only 5. All shapes are symmetrical. Each has 5 axes of symmetry. However, these facts do not clearly reveal the pattern. To find the pattern, let's express the shapes with numbers. 0 is the starting point. The first shape connects the numbers from 1 to 9 in order, and then returns to 0. Excluding the starting and ending 0, the sequence for this term is this. The sequence for the second term is this. For the third term, for the fourth term, to match the number of terms, we draw the second and fourth shapes once more and write down those numbers. The result is as follows. Each term consists of 9 numbers. Do you see any pattern? To make it clearer, I'll write down the original numbers. These are the last digits of the 1 times table. These are the last digits of the 2 times table, the last digits of the 3 times table, the last digits of the 4 times table. So the next numbers should be the last digits of the 5 times table. Following this pattern, let's draw the shape. This is the fifth term, which is my answer to this problem. This sequence is a pattern of shapes, formed by tracing the last digits of the multiplication tables. Now, let's draw the shapes for the 6 times table through the 9 times table. First, we find the last digits of each table. Then, we draw the corresponding shapes. Look at the shapes. The 1 times and 9 times tables have the same shape. The 2 and 8 times tables share the same shape. The 3 and 7 times tables share the same shape as well. The 4 and 6 times tables share the same shape. The 5 times tables has a unique shape. These shapes form a symmetrical pattern centered on the 5 times table. It's amazing how such a simple and clear symmetry exists within the multiplication table.